Hello.
Hello.
Ooh. Can you hear me?
Yeah.
Like nod your head. Go, caw, caw. No?
Caw.
Yeah.
Okay. Turn the volume up. Okay. What's the volume?
Sure. What the? Hey, somebody in the other room say something
They're pretty quiet.
really loud. Test. Hey, somebody over there say something again.
Yeah, it's still pretty quiet.
All right, now I can hear you. That's what I'm talking about. All right, I gotta finish giving you guys some stuff.
Okay.
All right, so let me screwdriver about those guys. And mystery resistors. Oh, and if you put your meter on there to find out what the resistance is, you lose. In other words, please don't, because we're going to find the resistance other ways. What?
Can you hear us now?
Yeah?
All right. So what are we measuring?
What are you measuring?
What physically are we measuring?
Hold your horses. Hold your horses. I'm behind. I got to get you guys the same stuff I'm doing over here. Okay? Hello?
Yeah?
Did you hear me?
Yeah.
What are you doing over there?
Holding our horses?
Holding your orifices? Your horses. Horses. I heard you. So none of you got arrested this weekend?
They didn't catch us. They were close, but no cigar. Right. Well, if it's a screwdriver, you don't have one tool. This is a mystery resistor. You don't take the tape off. You don't use your meter to find out the value. We're gonna do that. Why? Correct. That's what we're doing like that. Forecast. Your forecast. Where are your forecast? Okay. You want it? What? You cannot afford that. You have, wire. Yeah, you need wire. And you have the ability to strip that wire. You have that. I can hear you somewhat over there, but it's really quiet. So if you need me or need something, it's pretty quiet over here. I'll ask the voice. Quiet over here. Kevin. Yeah. Say something.
Something,
Say it again.
something.
Well, dude, all 13. No one watched it. What are you in, 12? You ever seen that movie? No. Like a decade. No, a decade. It's one of those movies that was on TV, like, have to watch it. Like the Rambo movie. Rambo. Shawshank Redemption. Right? Gavin,
Yeah,
you ever seen Shawshank Redemption?
yes, I have.
And he's like, well, I know about it. I have never watched it.
Press the button. I was picking on you because you're close. Well, I guess I could have picked on Paul. I thought you were closest to the microphone. So now you can hear me. I can hear myself over there. Boom. So what we have here is a failure to communicate. Now, I literally just opened these things up this morning, started playing around with them, and completely smoked the first one that I started playing around with. So don't feel bad if you do this. See that capacitor? Oops. Anyway, the idea here is we've got these little power supplies for you. So all those little, we have ILPUS, ROWAP. I can fix that. Because believe it or not, this is my right hand holding this thing. Shit. Excuse my language. There we go. That's more better. Okay, so what input voltage are we supplying this thing?
100 to 240 volts AC current.
Very good. But when we plug it in, what are we giving it?
120 volts.
It's not 100 and it's not 240.
Wow.
It's actually 120. People call it 110 a lot because a lot of components, like let's say this was rated for a 110. If you plug it into 120, is it going to be okay? Yes, but in reality, what you're getting out of an outlet is come on, Peter. It's inappropriate. I'm going to plug this into an outlet. Anybody ever done this before? So we are getting 116. What is this one? What does that say? AC, alternating current. What we're dealing with so far in this class is direct current. So when it says 100 to 240 volts AC, that's what you can input, 50 or 60 hertz. Which one do we have? 60. Where do they have 50 hertz? Europe and weird places that we don't care about. Then we're going to output 12 volts DC up to 1.5 amps. Cool. Another nice feature about these things that Steve ordered is it's got an on-off switch. And I don't remember which way is which. It'd be nice if they told you, but we'll figure that out. All right. So here's what I want you to do. I want you to wait till I come back.
Too loud? I'll turn it down. Good, bro. You can. Put you in between. Oh.
Are you watching? Doing? And attention? This is a twisty tie. Okay? Counterclockwise. Take that thing off. You guys get sick of my sarcasm? Oh, come on, dumbass, just do something. Okay, see this little thing right here? This is very important. Here's what I want you to do. See these? Cody, can you hear me?
Yeah.
Louder.
Yeah.
See these things? See this thing? Go like this. Bloop. Cut that thing right off. Get rid of this because nobody cares. Now you've got this little end of 2 wires. You take your fingernails. I know you guys have fingernails because hygiene is not your forte. I can tell. You can split those 2 things apart. Split them out, I don't know, a couple inches. Give yourself some time to work with. If I remember right, the wire that's got the little dotted lines on it is positive. I think that's going to be your plus how many volts? 12, plus 12, right? We're getting 12 volts out of this thing. So we're just going to strip a tiny little bit off of this, both sides, and we're going to check it for voltage and see what we're actually getting. And make sure that we have polarity right. So you can use your bench meters, or you can use your fluke or whatever. I'm going to use the fluke so you can actually see what I got going on here. If I'm right and this is positive and this is negative, I should put the colors of my meter up that way too, correct? And if I don't, if I get it backwards, what's the meter going to say? Negative 12 volts. That's the difference in polarity, right? So here we go. Volts DC. I'll put my positive on the dotted line one, and my negative on the one that doesn't have the dotted line one. And then I'm going to plug this in. So before I go over in the other room, we need a nickname for you guys. What's your nickname going to be?
Honey Badger.
The Honey Badgers?
Yep.
Okay, Honey Badgers. You all have little mini grabbers like these to use with your meter. I guess Honey Badgers, let me know if you need these. And you guys are probably using your bench meters for this, but if you don't, if you want to use your fluke or whatever your personal meter is, these will fit in there just fine. So I'm on DC volts, and then I'm going to plug this in, make sure my polarity is right. And I'm also going to knock them off the shit off the table here. Nothing. What does that mean? It means my switch is off. That's good to know. It looks like what the oh, I plugged the wrong one in. What'd you ask, Honey Badger?
Is the one with a little gas on the side? swing.
Yeah, you've got the power supply itself, and it comes out and it goes to this little toggle switch, right? And then it goes to the end that you just cut off. I'm gonna plug mine in. Nothing. So it looks to me like I might want to find a way to mark this or put a piece of tape on it or something, but it looks like if the switch is facing towards the plug, that's off. Towards the wire end is on. So I'm going to turn that on. I'm getting 12.5 volts DC. Is 12.5 volts enough to hurt you? Amps is a good question, but no, I'm not. I mean, if I put my finger in between there, I might get a little tickle, but no, I don't even feel it. If my skin was wet, I might. 12 volts DC is what you have in your vehicle, right? And you can touch your car battery without getting hurt. You can put your finger between the terminals, and those have a little bit more amperage. They can push more amps. They call them crank amps. But I even don't feel, I have felt it like if I'm working on something and I get sweaty and I touch something that's grounded, or you get a little, ouch, you know, kind of feels like static shock, static electricity, but anyway. Doesn't mean we should play around and not be safe, but at this point, this stuff is not going to hurt you. If you were to touch the, well, never mind, I won't even go there. Okay, so I got 12.54 volts going into this thing, and I know my polarity is correct. If I reverse it, it will say negative 12.54 volts. What's the difference? What's the difference, positive versus negative? Say it, say it louder. I have no idea what you said, but that's correct. Yes, it's the flow. Which direction are electrons flowing? Free electrons. So, circuit. One way, depending on if you're using conventional or electron flow theory, but it doesn't really matter. For us, if this is plus of the power supply and this is minus, and we got 12 volts, we know that in conventional current theory, flow, whatever it is, I, which is current, is flowing from positive to negative according to our meter and our power supply. And if I switch the leads and put like this, I'm getting negative 12 volts because I'm reading from in this direction. I'm reading in that direction, but current is flowing the other way. That's why it's saying, hey, this is negative. So it's telling you what the polarity is. Cool. So I'm going to turn my switch off. Wrong switch again. A damn switch. Oh, it's under my hand. Okay, turn my switch off. 0 volts. Take my mini grabbers off of these. Here, in our power. Bloop. Steve also, because he's really, really smart, got us these things. These are adjustable DC voltage regulator modules LM317. I haven't looked up the data sheet on these, but it's kind of like looking at a map when you need to go somewhere. You're like not cool if you can't figure it out on your own. Then it also gets me into a lot of trouble. But anyway, the first thing I'd like you to check is the first one that I opened up. Let me zoom in. Anybody know what this silvery aluminum part is? It's called a heat sink. Very good. All that thing's job is to draw heat away from this component inside here that's screwed in. The first one that I opened up was loose. So I would recommend that you check that little screw and see if it needs tightening at all. And mine does. You don't have to kill it, over tighten it. You just want to make sure it's good and snug so it does its job and draws heat away from that component. 10-4. So what do you think this component's going to do for us? Yeah, pretty cool, right? We'll have to look, maybe we should look up the data sheet on these before we're done so we can see what kind of current we can draw from this thing without hurting it. But two sets of terminals on this thing. V in ground, V out ground. So you got an input voltage and an output voltage. So what can you guess we're going to do next? Very good. Now we know which positive is the one with the little dots on it, right? And the ground is going to be the one without all the little dots. Twist the strands up a little bit, give them a little slap and tickle. Just kidding, you don't have to do that part. And then we're going to hook them up just how it shows. What's up?
I don't have a lot of those.
You're shitting me. Go. Say I never did nothing for you.
Trust me, I won't.
I'm pretty sure these have to loosen the screws up before you get them in there, if I remember right. Plus, this one goes into. Cool. Now the other side of this, the out, we're going to take some wire, wood wire, red and black. red out of V out. Black out of ground. And there is our adjustable power supply. Now I'm going to check voltage on this thing. So I got my meter hooked up to the V out and negative. Still on DC volts on my meter. And I'm going to turn this bad boy on, see what kind of voltage output I get. 11.16. So, how do you think we can adjust this? This little bitty screw. What is this component called? Rheostat potentiometer. It's an adjustable resistance. So I'm going to play around with mine for a second. And it's like counterclockwise will raise the voltage. Clockwise will lower it. Eventually it'll start going, moving a little faster. You can see it. Like if you want 8 volts, you can adjust it down to 8 volts. Cool, huh? So that is your power supply. Now what I want you to do, and I don't really have an official lab for you guys to fill out or do anything with. We're just going to mess around with this and voltage dividers and potentiometers and our mystery resistor. Wah, wah, wah. So I want you guys to pick a voltage between, I don't know, 5 and 10 volts. Get it set up on here. I'll give you guys a minute to do that. And oh, you guys don't have circuit.
My meter's fine.
How'd you blow them up?
I didn't ask the people to blow them off. They just turn on the multimeter and pop.
Hey, honey badgers. Make sure you have the polarity right when you hook these up. I think that's how I blew mine this morning is I guessed which one was positive and negative. So if you don't have the two inputs, yours just blew up. Is your polarity right? And all you have on there is your meter? Huh. Let's investigate that.
I think they just told us to put it in the wrong place. Because I didn't do it, he said mine got really hot.
Okay, so check your leads.
Yeah, I switched them.
You switched them?
Yeah,
What do you mean?
so now I switched these. And now it's.
Now it's fine? Okay. So because I told you that, yeah. So listen, honey badgers, you listening? Just because I told you that your positive is the one with the dotted lines on it doesn't mean that that's true, I guess. So it seems like if we hook it up backwards, we blow this capacitor. So make sure you check the polarity of yours. Yours might be different than mine, which is a bunch of BS if you ask me, but like you would think that they'd all be the same. But so let's try it again. Everybody make sure your polarity is correct. And you need another one then? Katie?
Yeah.
Candy? Katie.
No, mine.
Who needs another one? Just Katie?
So this is the plug.
And then you guys need somewhere to plug your, I see you.
I figured it out. You're good? Yeah. I unplugged a couple of these components.
Yeah, you can plug it in wherever you got.
Always fun to look at the
I want all the blown ones. I'm gonna line them up, take a picture of them, send them to Steve. Look what we did to your stuff that you just ordered.
Well, at least he thought ahead and ordered extras. Yeah, no, let's just do it, bring it home. The dotted one should be positive. Go with it. All right, here we go. Up and blow up.
Either way, you and me are. Good.
Which one?
Hey, have you guys looked at lab 5 yet? Lab 5? Anybody? Lab what? 5? From Tom? Okay, if not, that's okay, but what were the values of those two? 1.2K and 33K. Yep, you sure as shit don't have those. So, wait for instructions from Tom. Is it like get a due date or something? Wait for him to make sure he knows that. So, mine's starting to smell like smoke, and we haven't done it. Okay? No, don't do that. I know. Everybody else good though? Yeah. Put it on some kind of voltage between 5 and 10.
I'll send that to Steve. Should I send it to him with the middle finger emoji? Just send him a big giant ball of these blown up capacitors. Do you guys get all hooked up and got something between 5 and 10 volts? And okay. Message, Steve Flynn. Picture. Here, I'll show you. Because this is how I roll. Picture. Middle finger emoji. All right. What are we doing? Blowing stuff up. I'm gonna turn mine off temporarily here. And I want to set up. So I want to set up a circuit like this. This is going to be your mystery resistor, RM. This is going to be your potentiometer. I'll call it RP. And that has a little symbol like that. And then this is going to be, we're going to measure current. And I know that I have 8 volts DC. You can write down whatever you want on yours. So this is my mystery resistor. On my breadboard, let's look at, you should all have one of these little guys in your parts kits, I hope. That is a potentiometer, the same kind of thing that we have over here. It's a variable resistance. And I'm going to show you guys how these things work. So there's 3 prongs on this thing. See the 3 prongs? I'm going to plug it in so all 3 prongs are in a different row, and that's important. If I plug it in this way, what's the problem with that? They're all in the same potential, so it doesn't matter what you do with those. You're not going to get anything out of this potentiometer. So make sure you plug them in vertically, so to speak. And then I'm going to put some lead wires coming out of those 3 spots. So we can do some measuring. So how does this thing work? Well, there's a resistance that's fixed between the top and the bottom leads. And between those 2 resistances, there's a wiper. And if you really look closely at this thing, I don't think I could even zoom in close enough to show you that picture. But it shows you basically the schematic of a potentiometer. You see, if I can. Nope. But right here, I will draw this thing on paper so you can see it. It looks like this. It says 1, so that'd be pin 1. 3 down here, and 2. Doesn't say 2, but there's this little arrow here. What that means is that pin 2 is on a wiper, so that as it goes this way, what do you think happens to the resistance between 1 and 2? It goes down. So if I move this arrow to up here, the resistance between 1 and 2 becomes less. The resistance between 2 and 3 becomes more. Make sense? What 1 and 3, that resistance, does that ever change? No. So we can find the total value of this potentiometer, the fixed value, if we measure ohms from pins 1 and 3. So I'm going to do that now. So I got my guy turned off. So I'm on 1 and 3, and then I'm going to take this thing to resistance. 98.3 kilo ohms. And then you can see that if I turn this wiper up and down, it doesn't really change. Okay. So if I put one lead on the middle, so now I'm on pins 1 and 2. I'm getting 17.2 kilo ohms. If I turn this thing clockwise, what do you think is going to happen to the resistance? It's going to go up or down? Down, because I'm moving that wiper closer to that pin, correct? If you turn it clockwise, you'll start to see that number go, up. They lied to us. Well, that just means that it works opposite of the way it looks like on the picture. But so I can go all the way up to 98.3 kilo ohms and all the way down to basically 0. All right. So if I put this on as close to 20 kilo ohms as I can, what do you think the resistance is between the wiper and the red lead? If it's 20 kilo ohms from here to here, what do you think it is from here to here? Just the difference of the total and that. Make sense? So if this was 98 kilo ohms, I think it was, from here to here, and this is 20, if I switch this lead to the red one and read between those 2 points, I should get 78 kilo ohms. Boom. Like I said, 79.5. Just kidding, close enough. All right, so what I want you to do now is pick some value in between somewhere. So not maximum, not minimum, some other value in between there. We're going to use this, and we're going to use current to find the value of our mystery resistor. So remember, this is how I'm setting up my circuit. So I'm going to have my 8 volts coming in the positive and negative. Boom. Boom. I'm going to take my middle pin, so pin 2 of my potentiometer, and I'm going to jump right over to the negative. So basically what I have so far is this. I need to go positive to my potentiometer middle pin. For now, I'm skipping the amp probe being in the middle there. I'm just doing everything else. So right now, if I go positive to the middle pin, I have this. To complete the circuit, I need to go from one of the other two sides to our mystery resistor, correct? And then I'm going to use that same resistor just to complete the circuit by putting it on the negative side. Oh, that's not my mystery resistor. Where's my resistor? Here it is. So, using this circuit, how can we find the value of the mystery resistor without just measuring resistance? Any guesses?
Measure voltage and measure current.
Measure voltage in what?
Current.
Hey, instead of doing that, why don't you just walk over here and just scream in my face every once in a while? Just kidding. I appreciate you saying that so you're here. Yes, we're going to measure current. That's why this is in here. And what kind of circuit is this? Series or parallel? Series. So the current at this point will be the same anywhere else, correct? So in order to read current in our circuit, how do we have to do that with our meter? That's right, we have to break the circuit. Very good. On my meter, and if you're using your bench meter, that also, we need to break the circuit, correct? I need to change my red lead over to 10 amp fused to read current. I'm going to go to DC current. I'm going to put my meter leads in between two spots on this circuit. So how can I do that? I'm showing it on the print between the positive and the potentiometer. So I can do this. In order to get the polarity correct, I need to put my red lead on the side of the positive. So I've broken the circuit here, right? This is circuit complete, and I've just broken it. Now I'm going to put my red lead here, and my black lead here. And what that does for me is it uses my meter to complete the circuit, and then my meter will read current in the circuit. I know that I'm putting 8 volts on it. I've got some kind of variable resistance here, and I've got some kind of mystery fixed resistance here, right? So let's read current. Ready? Whoop. Nothing. French toast. You guys getting 0?
Yep.
What the? Yeah, I'm kidding. It's a bunch of crap. Turn that off. Run the circuit this way. Check voltage. Thank you. We got 8 volts. Why am I not getting any current? That's why. Because just with this resistance alone, we're getting, I'm getting 80 microamps, so my meter doesn't have the ability to read that low. I can read milliamps, but not microamps. So let me try this. Just using the mystery resistor. I got 1. Crap.
Yeah.
So how many,
It's 71.
so you're using your bench meter, you can,
Yeah, the big meter will
okay,
go down that low.
I guess we have to use our bench meter.
Yeah, come
All right. Honey badgers, do you understand what's going on? Okay, good. I'll be there in a minute. So we need to do two things. We need to read current, our bench meter. So I got +8 to there, to here. And I got my meter reading. Okay. So I've got 152 microamps. And if I change the value of that potentiometer, I get that. Using that value and the voltage across the resistor, can we figure out what the value of the resistor is? Yes, no, maybe? So if I check DC volts across the resistor, 1.525 volts, and I have 153 microamps, I can figure out what the value of this resistor is, correct? Correct. So your job is to tell me what the value of that mystery resistor is, and once you do, you can go home. What do you think about that? And don't just blurt it out. If you do that, you have to stay for another 5 hours. Just kidding. Go check on the other guys, on the honey badgers. Come on, Harrison. You know what? Here. Write it down. Got it? Do you understand the problem we were having with reading current with your load? Oh, I don't. I would have. You need that. Yeah, you need that. If our food treat that well.
doing this lab, I want you guys to put power plastic together and then use them with the resistor. Good lab. Good. That way you guys don't have to answer these questions. You turn them to shit. You make me pretty. Just kidding. Did I tell you I love you guys?
Not yet,
Oh,
but I appreciate it.
So on mine, just so we're all on the same page, 152.9 microamps, how many amps? Right, 0.000, that's milli, 1529. That's gonna be, this kind of stuff is gonna be very important for you guys to understand. So if you're having issues with that, make sure you see me. Everybody else good? Hey, you good?
I have no idea what you're doing.
What hope do you? Yes,
I mean, it was like a what? Oh, that's it. Yeah. I mean,
Let's just leave it what it's like. You read vocals.
yeah.
From my circuit. Make sure you're listening. And then. Not sure what that is. One of the is the function to the current in this circuit. Hello? Hello? What's up? Hey. Yeah. Oh, we blew them up. Oh, no. One of them actually was wrong. Yeah. So those power supplies. No, so. No, so we were checking polarity. Okay, so it looks like this one worked there. Oh, everybody hooked them up. And all of a sudden we started hearing this pop, pop, pop. I think we got 4 of them total, right? Two. So, okay, 4 of them. So we're good. They wanted me to send you a picture of it. No, it's really, isn't it? I mean, it's also got the little sticker. Sorry about that. Oh, yeah, for sure. Yeah, we all got one and that was it. Yeah. Are you coming in? Okay, the other box was upstairs. I gotta put it up with these guys. Okay. Yeah, so how do we move this? Now it's simple. You turn that switch on. Yep.
I think I already got it on.
So you're in time there. And then. Hold. Lie about it.
Yeah.
However you do it.
Alright.
But in order to do that, you need to break the circuit for the meters and Is it on by then? went anywhere in the circuit. We are good to go. Yeah. I'll see you later. All right, man. Well, I think we can do it. Instead of moving it to the rail, and then I go through the knee around the black side, back under. Okay. This, if I do that. Yeah. That's good. But if you put a meter in three, that's how you do it. Now it's just a meter.
Yeah.
Now if you turn it on. You should be able to kind of monitor it. You got actually one time. Using that, and use your meter to open the contact. You have voltage, you have current, you can only go up. All right. Yep. Already on. Okay. How would I do the meter? So I had to blew it up. No, not right here. Sorry. It's the thing. It's the first time. Oh, yeah, yeah. So I was. And, he has mine. I got a comment. Oh, you're done? I put that down. I believe it is. This is what I got from your side. I'm telling you. This is what I got on. Okay. That's what I got from the package. Well, you can be looking at this. How do we? Yeah. Yeah, this is 11. Okay, down to 25, yeah. Cool. Now. Oh, that's the pause. Now, between the tongue. it might be, take that resistor out and measure. Okay. Then we do that. Find out the voltage between here and here. And we find out the resistance. But seriously, we can current and yeah, we can break that. Right. So, it's flat. Well, maybe,
Oh, yeah, I know that. I got like the. That's not what I got. Oh, that's what I got from Franklin when I read it. So I'm not really sure why. I mean, this is the right. Yeah, now.
I have a whole kind of and I don't know. So if you read the old stuff, you know we have that long time. Old stuff. I didn't know. Yeah. Yeah.
Boom. Yep, thank you.
Yeah, hold on a second.
Make sure you're using both hands, not my
Yeah, I need to be on. Let me do that again. Here.
Hold on.
Okay. That's why I was doing this. see what the set back, right? Oh, yeah. Yeah. Oh, no. What are your numbers? I do not have. Anything else on the deal? Do you have time, Carl? That good? Yeah, I'm good.
Hey, can you guys hear me?
Yeah, yeah.
What'd you get for the value of your resistor? Anyone, yell it out.
9,981.
Right, that's a
Oh.
10K ohm resistor. If that's what you got, you're free to go. Sorry it took me so long. Nope, I don't have one. Here, we got this one. What are your values?
One, okay. And 188. 083. Okay.
So 1.8 divided by that should give you the amount of ohms.
You figuring all this was up?
Yes. The 10K.
Okay. Yeah. And now I realize what I was doing wrong. Put a -3 instead of regular 3.
Oh, for that engineering notation?
Yep. Have a good day.
You too.
I will try.
Cannot believe I blew up that.
It's not your fault. I did it too.
Some of the things. Yeah, that's the flying. I didn't even think it was gonna blow up. Then I saw the polarity was negative. Like, gosh.
Guys good? Yep. Understand it all?
I got his piece that flew at me.
Yeah,
All
when
right.
that thing exploded, I didn't see that.
See you, man. See you, brother.